Okay, so as we get into the electrolysis of aqueous ionic compounds, we need to consider that water, which is obviously present in large concentrations in an aqueous solution, that water can also undergo oxidation and reduction. Okay, so what happens when water is reduced and what happens when water is oxidized? Well, the good news is that for paper 2, what happens is in the data booklet. It's given to you. So we know that reductions are shown going to the right. This table shows reduction half equations if we think left to right. And so the reduction half equation for water, so water gains an electron and creates hydrogen gas and hydroxide ions. So our two products, the main product would probably be referred to as hydrogen gas, or H2. We also make hydroxide ions, and hydroxide ions are what we associate with base. And so you could actually see that this was happening. You could check the pH of the solution near that electrode, and the pH would be increasing. Or you could use pH paper to notice that the pH is increasing near that electrode. So these are the products when we reduce water. When we oxidize water, the oxidation half equation we know from this table will always be written going to the left. Those show oxidation. And when water is oxidized, it's shown down here in the second red box. And when water gets oxidized, we lose electrons. We form oxygen gas. And we form hydrogen ions. Okay, hydrogen ions we associate with being acid. And so the pH near that electrode will drop if this process occurs. And we can measure that with a pH meter or with pH paper, turning a different color. Okay, so this is the oxidation of water. So they're in table 24. They're there for you. You need to know which direction is which, that going to the right is reduction, going to the left is oxidation. You can see that neither one of these processes are spontaneous. They both have negative electrode potential values. The oxidation being even less spontaneous than the reduction, but both of them, you have to force these things to happen, and so that's how we're gonna force them with electricity. This is electrolysis, so we're forcing this non-spontaneous process with electricity. Okay, but actually, you need to know something about these processes, these half equations, even for paper 1. So the nice thing, though, is that if you know your old definitions of oxidation and reduction, it's pretty easy to remember what the products are. The old definition of oxidation had to do with oxygen, or gaining oxygen, and the old definition of reduction, one of them, is gaining hydrogen. So the nice easy thing to remember is that when water gets reduced, the main product is hydrogen. So when you think of reduction, one of the things you should think of is hydrogen, and that conveniently is the product formed when water gets reduced, the main product. The other ions like the hydroxide and the H plus are also products, but we tend, they're in the solution, so we tend to talk about the element formed. The nice thing is that when water gets oxidized and undergoes oxidation, the product is oxygen. Okay, now if you look at the half equations, you can see that this one's written with 1 electron and for every half hydrogen. So if I made that 2 electrons, I'd get a full hydrogen. So I get 2 electrons makes 1 mole of, 2 moles of electrons makes 1 mole of hydrogen. And over here, 2 electrons makes half a mole of oxygen. And so if I wanted everything to be whole numbers, I could say 4 electrons would make 1 mole of oxygen, and 4 electrons would make 2 moles of hydrogen. So if I made that 4, then that would be a 1. And so you can see that the ratio is you'll make 1 mole of oxygen for every 2 moles of hydrogen if these two things are happening at the same time. It's a 1-to-2 ratio. So it takes 4 electrons for 1 mole of oxygen, and for 4 moles of electrons, you get 2 moles of hydrogen. So that ratio is another thing that they would expect you to know. But the nice thing is that the ratio is already in the formula of water. 2 hydrogens for 1 oxygen. So it's it's just remembering that this information is not that complicated. It's already sort of in the water. You can just find it, okay? So in paper 1, you would be expected to know that when water is reduced, it forms hydrogen. When water is oxidized, it forms oxygen. For the same number of electrons, you will form twice as much hydrogen as oxygen, so a 2-to-1 ratio. And that's pretty much what you need to know for paper 1, and that's helpful sort of foundation context going in to what happens when we do electrolysis of an aqueous ionic compound. So knowing that these processes can also occur, water can also be reduced or oxidized, is fundamental to understanding what will the products be when I now use electrolysis on an aqueous ionic compound.